Hello again, students. For this video, we'll be validating those arguments in our previous video. So for our learning target, you are expected to determine the validity and falsity of real-life arguments using logical propositions. Valid argument satisfies the validity condition, that is, the conclusion Q is true whenever the premises P sub 1, P sub 2 to P sub n are all true. In another way, for a valid argument, the conditional or this propositional form should be a tautology. So, a tautology class, that is a compound proposition that is always true for all possible truth values of the propositions that occur in it. So later, I will be showing you an argument which is considered to be a tautology. Okay? So if it is a tautology, that is considered to be a valid argument. Okay, take note on that. An argument which is not valid is called a fallacy. So in a fallacy, it is possible for your premises to be true while the conclusion is false. So later, I will be showing you examples of an invalid argument. Now, let's determine if the given argument is valid or not. So in our previous video, we symbolized this argument, and this is the propositional form or the symbol. Now, let's generate the truth table of the propositional form. Now, I'll be teaching you how to input the symbol correctly in this truth table generators. The link is in your learning guide, so you may copy that and paste it in your browser. So this generator is somehow strict in terms of inputting the correct symbol, so you have to follow the symbols for the various connectors, and then we have to have a well-formed inputs, because there are times that they will not generate the table if it is not done or input correctly. Bracket, parenthesis, P implies Q. So for conditional, that is, we will be using this one. Okay, that is greater than a symbol. And then Q, close parenthesis. And then and is this one. You may copy that one, then paste it here. Next is negation of P. So negation of P, and then bracket implies, so the implication is conditional, this one. Okay, for a while. Okay. And then negation of Q. So negation of Q. Okay, that's it. So let's generate the truth table. So as observed, class, as what I've mentioned earlier, this is parang strict gid siya. The string you entered contains the following unrecognized symbol. So hindi ni-recognize yung bracket. So that is why we will be replacing this with a parenthesis, because hindi siya ini-recognize. So let's try this. So one of the formulas you entered is not well formed. So maybe this one, they will not allow parenthesis for negation. So let's just delete this one. Okay, so let's generate now. Okay, that's it. So this is now the truth table for the given symbol or propositional form. Okay, so let's try the truth table generator app in our phone. So I am here now in the truth table generator app on my phone. So let's generate the truth table of the given proposition. So we have, there's no bracket here, so we'll just use the parenthesis. Okay, so there's another symbol for negation, so you can still use that one. Negation of Q. So after that, click or press this head of a duck, and this is now the result. So this is the truth values of the given propositional form. You can also click if you want to have it in full or all results are shown. So this one. So this is the red color here implies the truth values of the different combinations of the truth values of the propositions P and Q. So based from this truth table, we can see that there is a case where the premise is true and our conclusion is false, which by definition means that the argument itself is invalid, and that is supported by the fallacy of denying the hypothesis. Since it doesn't mean, class, that since it is not sunny, we can conclude with certainty that Ben will not go by King. So it might have that there is an emergency or an important thing that Ben will do at that time, which leads him not to go on by King. So somehow, class, when we read again this argument, it is not that clear that a fallacy is being committed. But because this is a formal argument following a strict form, even if the conclusion seems to be true, the argument is still invalid. So this is why also fallacies can be very tricky and deceptive. That is why we really need to generate the truth table of this given argument so that we can conclude that a given argument is valid or not. Second argument, that is, if it is rainy, then the pool will be closed. It is rainy, therefore the pool is closed. So let's determine if this argument is valid or not. So wherein we know that this is its corresponding symbol. See on the given truth table, the proposition is true in every row. Tautology. So for tautology, that is true man for all possible truth values. And if it is a tautology, then the argument itself is considered to be valid. And this argument is supported by modus ponens. Because it is really true, class, or this is really valid that if it is rainy, then the pool will be closed. So since it is rainy, therefore, the pool is closed. So for our third argument, this is the truth table, and as you can see, there is a case where the premise is true and the conclusion is false, which by definition, this argument is considered to be invalid, and that is still supported by a fallacy of affirming the conclusion. In class, the truth of the premises does not guarantee the truth of the conclusion. You can still learn discrete mathematics without doing every problem in the book. So it might be that you do some research or watch videos related to discrete mathematics and not doing every problem in the book. And that makes it an invalid argument. And then for our fourth argument, so this is also the truth table. So as observed, it is always true for all possible truth values of the propositions that occur in it. So meaning, since it is all true and it is considered to be a tautology, therefore we can say that this argument is considered to be valid. And it is supported by hypothetical syllogism or reasoning in a chain, because when you tend to observe the propositional form, there is a relationship called a transitive relationship where P implies Q, Q implies R, therefore P implies R. And for our last argument, as observed on the truth table, it is a tautology because it is true for all possible truth values of the propositions P, Q, and R. So meaning we consider this argument as a valid one, and it is supported by one of the rule of inference, which is resolution. And that's it for today. I hope you're able now to determine if a given argument is considered to be valid or not. Thank you for watching and see you in our next video. Bye!